Mellin transform of cosine integral function. So over here in this video we are basically finding just the Mellin transform, that means x to the power alpha minus 1 and times function integral from 0 to infinity. So first of all, let me define the cosine integral function. This is defined as negative of the integral from x to infinity of cos t by t dt. This definition is made by having concern over the convergence of this integral, as well as this negative sign, and the way it's written ensures that the derivative of the cosine integral function is just cos x by x. Yeah. Those are considered while making this definition, and that will help us while solving the problem. Yes. Now let's go to the integral. Okay, so over here, if we change cosine integral function to its integral form, then it will simplify in some ways. Let's see how. So basically negative sign, integral from 0 to infinity, x to the power alpha minus 1, and then over here integral from x to infinity of cos t by t dt and then dx. Yes. Now let's take this. This is constant in the world of t, like this takes inside and then interchange the integrals. But before that, let us try to make this integral in terms of numbers. So to do that, what you can do is basically divide t by x. Yeah. If we divide t by x, we get integral from 0 to infinity, and then x to the power alpha minus 1. Now integral from 1 to infinity. T is just xy. Yeah. And then just xy, and now x is a constant over here, so dt will just be x dy dx. You see that x cancels out, so that's a very good thing for us. Now let's interchange the integrals, order of integrals, and take this inside and then interchange the order of integrals. Integral from 1 to infinity, integral from 0 to infinity. Yeah. And then we have x to the power alpha minus 1 cos of xy by y, and then dx dy. Now if we take 1 by y outside, we can see that this is just the Mellin transform of the cos function. Yeah, x to the power alpha minus 1, and into the world of alpha, and cos of xy dx dy. Over here in the world of x, y is just a constant, and alpha is the world that this function will go into. So we know that Mellin transform of cos a y will basically just be gamma of alpha and then cos of it will be pi alpha by 2. Yeah. And also over here, since we have a constant y over here, that will be y to the power alpha and then dy. This is just the Mellin transform of cos ax. Yeah, basically if it was integral from 0 to infinity t to the power s minus 1 cos at, if it was like this, and then dt. Yeah, in this case it will just be gamma of s and then cos pi s by 2, and over here divided by a to the power s. So this is the general formula for the Mellin transform of cos at, and that's what we have used over here as well. Now we see that this can be written as gamma of alpha cos of pi alpha by 2 come out. Yeah, and we just have the negative sign over here, integral from 1 to infinity of y to the power minus alpha minus 1 dy. Now this is pretty easy to integrate. Yeah, this is just the normal power rule integral that we have been doing since our high school. Yeah, and the integral of this function is y to the power minus alpha by minus alpha, which goes from 1 to infinity. Yes, and then this is just minus gamma of alpha cos of pi alpha by 2. Yeah, and this over here at infinity it is 0, minus minus plus, it 1, this is a 1 to the power alpha, so 1 by alpha, and we get the answer. This is a pretty good neat answer, pretty like beautiful answer I should say, minus gamma of alpha by alpha cos of pi alpha by 2. And that's what the product of the rival functions gets to. Minus gamma alpha by alpha cos pi alpha by 2. Let's see if that's correct or not. Yes, it's exactly correct. To talk about the flow of the solution, first of all we use the definition, and then interchange the integrals and evaluated the Mellin transform of a known function. And if you want to like derive this, just use the fact that cos of theta can be written as e to the power I theta plus e to the power minus I theta by 2. You can use that to find its Mellin transform. And then after that we just had to integrate an easy function, and then we integrated, we got the answer. So this was it. This was heavily based on the Mellin transform of cosine function. And yeah, hope you enjoyed the video. Thanks for watching, and look forward to seeing you in the upcoming videos too.